Alright guys, sorry, my computer is not working with me very well, so we're going to try to make the best of it. So we're going into mean absolute deviation. It is a set of data in the average distance that the data from the mean. So for our first example, we have the table shows the maximum speeds of 8 roller coasters. We're going to determine the mean absolute deviation of the set of data. Then we're going to describe what the mean absolute deviation represents. Let me see if I can make it bigger since it won't let me present. Alright, so our first step is you're going to have to determine the average, which is the same thing as mean of the data it gives us. So if you look at that table, we have 58, okay, plus 88, plus 40, plus 60. Make sure you use a calculator. You can use a calculator now. 88, oh man, not my day. 58 plus 88 plus 40 plus 60 plus 72. Wait, 72, 66 plus 80 plus 48. So, okay, we get 512, and then with the average, we're going to have to divide it by 8. So add up all your numbers, divide by how many is in your set. Okay, so we get an average of 64. Okay, so we get our mean of 64. So now our second step says you're going to determine the absolute value of the differences. So differences we know we're going to subtract between each value in the set and the mean. Okay, so we just found out our average is 64. So you can kind of see this red line, but it's counting by 2. So we know this here is our average of 64. So now what we're going to do is we're going to subtract it from each of our sets. So here I already put your data set on a number line for you. So normally you would have to create your own number line, plot each of your data sets. It doesn't matter if you count by 2s or 1s, just make sure you keep your number line consistent. All right, so what we're going to do first, we're going to go for our first one, which is 40 to the mean. So we would have 64 minus 40. Okay, we get 24. So now our next one, what number is that? 42, 4, 6. This is 48 to our mean. I'll do a different color. So we get 64 minus, what did I say, 48. Okay, when I subtract that, I get, not 26, 16. Okay, and then I'm going to do it again. Let's see what number is that. 52, 4, 58 to our mean, so 64 minus 58. Okay, we get 6. And then lastly, 60 minus 64. You can barely see that color. Okay, so 60 minus 64, we get 4. So here's each of our numbers, I'll circle. And then we're going to do the same thing to our other side. Okay, so our first number we have is 88. So 88 minus 64, we get 24. Okay, and then our next one we have is what, 80. So 80 minus 64. We should get 16. What's that, 72? So 72 minus 64. Right, 72 we get, it should have been the same. Did I subtract wrong? Okay, we have 8. And then our last one, 64, so 66. Oh man, I wish my computer worked really well. All right, so then our last one, that should be 66 minus our 64, which we get is 2. Okay, so with all that and all those numbers we found the difference of, okay, let me circle these. Okay, so now what I'm going to do is find the average of those numbers. Okay, make sure you pause the video, catch up, but I'm going to go ahead and erase this and move on. So what we're going to do now is we're going to add our 24 plus 16 plus 6 plus 4 plus 2 plus 8 plus 16 plus 24, and then we're going to divide that by our set in our data, which is our 8. Okay, again, make sure you use a calculator. So we have 24 plus the 16 plus 6 plus 4 plus 2 plus 8 plus 16 plus 24. Hopefully I got those numbers right previously. We get 100. We're going to divide it by how many is in our data set. So we get 12.5. Okay, and we needed to describe what the mean absolute deviation represents. So since we found out that it was 12.5, the mean absolute deviation is 12.5. Okay, this means that the average distance each data value is from the mean is 12.5 miles per hour. Because if you go back to our table, we're talking about miles per hour. So pretty much what you're doing is finding the average, subtracting, and then finding the average again. Okay, so this next slide I'm going to pop up is your you try. We'll talk about it in class as well. Okay, so go ahead, pause the video. Whoops. Go ahead and get your you try. We're going to start on the second example. All right, our second example, we're going to compare variations. So here we have the top 5 salaries and the bottom 5 salaries for the 2010 New York Yankees are shown in the table below. Salaries are in millions of dollars and are rounded to the nearest hundreds. Okay, so we're going to determine the mean absolute deviation for each set of data, and we're going to round to the hundreds. So first what we're going to do is we're going to determine the mean of the top 5 salaries. We're going to look at the data set on the left side. Okay, so we're going to add 33 plus 24.29 plus 22.60 plus 20.63 plus 16.50. Okay, we get 117.02. We're going to divide by 5 because that's how many is in our set. Okay, we get 23.404. We're rounding to the hundredths place. Okay, so we'll get 23.40. Okay, so then our next step, we're going to determine the mean absolute deviation of the top 5 salaries. So now what we're going to have to do is we're going to have to subtract. Okay, so we know we have 23.40 for the average. So I'm going to take each number in our data set. So we have 33 minus 23.40. Okay, and then the second one is our 24.29 minus 23.40. Okay, and again, you'll use a calculator, but it won't let me write and calculate at the same time. So I'm just going to show you how you're going to set up for each one. Let's see. 23.40 minus, where am I at? 22.60. You're going to do it. Make sure you do it to all 5. You got to find the difference. Okay, go ahead. You can pause the video if you want to write all this down. but what I'm showing you now is just the setup. Okay, so you're going to subtract your data from the average that we just got of 23.40 from all 5. Okay, whenever I subtracted each of those, we get 9.6, 0.89, 0.80, 2.77, and 6.9. So now what we're going to do is go ahead and find the average of that. So 9.60 plus 0.89 plus 0.80, 2.77, and 6.90. Okay, we get 20.96. We're going to divide that by our data set of 5. So we get an approximate average of 4.192. We're rounding to the hundredths place, so we get 4.19. Okay, so then what that means is that the mean absolute deviation for the top 5 salaries is 4.19 million. So now we got to determine for our bottom 5 salaries. So we're going to do our same step. Okay, we're going to find our average for the bottom 5 salaries. So we have, make sure I did the right one. Yep. Okay, so we have 0.45 plus 0.44, 0.43, 0.41, and 0.41. We have 5 in our data set, so we're going to divide by 5. We get 0.428, rounding again to the hundredth, so we're going to round to, our 8 tells a 2 to go up. So we get 0.43. Since we found the average is 0.43 or 43 hundredths, now we're going to have to subtract our deviation from our 5 salaries. So our first one we have is 45 hundredths minus 43 hundredths. So you're going to do this for each one in your data set. Okay, again, I'm just going to write it all down for you so you can see the process. C.43 minus 0.41, and then the same thing for the last one. Okay, so we're going to subtract each one. Okay, so when we subtract each one, I get 0.02, so we're going to find the average of everything we subtracted. Okay, we get 0.07. We're going to divide by 5 because that's how many numbers are in our set. We get 0.014, again rounding to the hundredth, so we get 0.01. Okay, and what that means about that data set is that the mean absolute deviation for the bottom 5 salaries is 1/100th of $1,000,000. Okay, and then what that means is that the mean absolute deviation for the bottom 5 salaries is much less than that for the top 5 salaries. So the data for the bottom 5 salaries are closer together than the data for the top 5 salaries. Okay, and lastly, you have your own you try of comparing. Again, I will check this on Monday. If you have any questions, I will answer you on Monday. And Monday we will go into Pythagorean theorem, and there won't be a video on it. I'll go ahead and teach that one in class.